All right, welcome back to Horn Online Training, Training Module 7.2. I'm your trainer, Edwin Tunney, Training and Technical Specialist for Horn USA Incorporated. Today's topic is GPS geometries, so grooving part-off system geometries. Before we get into the micro geometry or the working geometry of the insert, I think it's important to understand some of the macro geometry or the shape of the inserts that are available. So we'll go through these really quickly. Series 209, you have grooving and profiling. So you have basically a radius insert and then a grooving insert, the 209 system for internal grooving. The 216, very similar. You have a square end. You also have a radius. The 223, on the 223 system, you have geometries for grooving, circlip, part off, and finishing. So you see the NC geometry here for finishing and circlip grooves, standard grooves, and then the C geometry for part offs. The 217, a lot of different shapes in the 217, especially in corner reliefs and thread reliefs. So if you need to make a relief behind a thread profile or a groove or a circlip groove or a corner relief, either a square one like this or a radius, you can do that with the 217 system. The 224, mainly you have groovers, you have some threading, you have standard groovers, and then also grooving with side turning, profiling, finishing of grooves, and part off. Same with the 229. The 224 and the 229 are two very similar systems, with the 229 having just a little more reach on Tmax than the 224. But you have groovers, you have side turning and grooving, you have profiling tools like the K and the KF, part off tools, finishers, and also threading. 312, you have groovers, you have circlip, you have radius, full radius groovers, you have groove and turn, you have poly V belt, face groovers, and then also corner relieving tools like we saw with the 217 system, and then plunge and turn tools as well. 315, you have form geometries for grooving, full radius, face groovers, also face groovers that you can get alongside a boss, and threading. 316 is mainly a grooving system, so you have square end grooving with the 52 geometry and the FY. Then the 64T, not shown here, but you also have threading with the 64T. So you have standard grooving, part off, full radius grooves, and then you have some geometries, the 1A and the DL. So before we talk about all the different groovers, and just of note, I'm not going to go down the list of every single geometry that we have inside Horn. There are over 26 different types of geometry in our portfolio. And so, but I want to give you the top ones so that you can get going, and then you may make use of the other geometries over the course of applying Horn product. So why so many geometries? So first thing is chip control. So what are the needs of the chip control? Do you need a tighter chip? Do you need the chip to be creased more so that you avoid the sides of the groove? What are those chip control application options and requirements? Application. So what do you need to do? You need to groove. Do you have a partial plunging? Do you have profiling, turning, part off, or finishing? So that helps define what geometry you would use. How much protection do you need on the insert? So how are the cutting edges protected from damage not related to regular flank wear? So if you're using a part off insert, this is the 3V2 geometry with internal coolant. So how are you protecting that when that is deeper into a part and you're parting off a component? Dynamics, what forces do the cutting edges impart on the workpiece? So you not only need to know what the impact of the dynamics of the cutting are in relation to how much damage you take on the insert, but in a lot of cases with smaller parts, you need to worry about how much force you're putting on the part in order to make sure you don't bend it or deform the part during grooving. So what are the dynamics of the application? So just going over a few sort of telltale signs that you can see on inserts if they're made for just strictly grooving. So every insert in the program, I believe, will do just straight grooving. It's kind of a given, but some are better at it than others. Some are designed specifically for grooving, like the HR geometry. So you can see a couple of features here. A very high plateau. So the plateau is the part that makes the chip sort of curl, and then in the center it's going to crease the chip. So it's going to make the chip very narrow, in more narrow than the groove that you're cutting. So you don't get the chip doesn't snag on the groove sidewall or make a bad finish. Also the 3, so the 3 is another one, and the H are all designed for grooving. So the H has a big heavy plateau in the front, so that's going to curl the chip and make it curl up tight in a grooving application. You can also look at the edge protection. So inserts for deeper grooves, they tend to have more protection on these edges because you want to have that, especially in a part-off application, you want to make sure you protect that, protect the size of the insert. And then you can also find internal coolant. Side turning inserts, those are a little easier to spot, like the L, the 5, and the A, because like on the L here, you'll have geometry for side turning. So you'll have chip breakers that enable you to side turn and also roll and break a chip. Same with the 5 and also the A. Generally, you're going to have some kind of a positive top rake so that you can side turn, and also a clearance on the side for that application. Partial cutting. So one thing that comes up in grooving is partial cutting. So some geometries are better than others, but for instance, the horn A geometry, the 3V and the E are designed for partial cutting. They really put the chip right in the center. You'll see that in a partial geometry, just look at the top of it and you'll see that the chip is funneled to the center of the insert. So this is the A geometry and this is the 5 geometry. So you can see that with a 5 geometry, once the chip passes these little bump outs here, these little bumps, the chip can go from side to side. So you can get damage on your finish, or you can also, worst case scenario, get damage on the insert if the chip rolls up and it goes behind your insert and behind this flank face, this face here. So be aware of that. Some geometries are not good at partial cutting, so you want to be aware of that. And then finishing. So finishing, one of the signs that an insert is a finishing insert is that it usually is ground. So it's usually ground around the business end here, the cutting profile of the insert. So we have the NC, we have the ZG, the N, and then we talked about this in new products training, the FB geometry for finishing. So finishing, the telltale sign, you'll see actually a little bit of cutout in the center, or in the case of the FB, like a big radius, where this is not putting too much pressure on the tool, on the part you're machining, so it reduces the chatter and improves finish. Part off inserts. So part off inserts tend to have, those are telltale. They'll have a alpha angle here. They'll be handed. So they'll be left or right hand. Sometimes they're neutral, but you'll find they'll have a handing to them, and then they'll have an alpha angle that might be 8, 12, 15 degrees. And then you'll see edge protection. So again, like deeper groovers, a part off tool needs to have some protection so that when you finish the part off, it actually protects this from damage when that material departs from the parent material. So let's talk about some specific geometries. As I said, we won't go over all of them, just kind of the ones, the fan favorites here. The first to talk about is the 3. So the 3 is pretty widely used among all the different series of tools. And the 3 geometry is good in all the different ISO materials. None of these are going to pop up in hard materials. So there's not a geometry for hard materials in any of the current horn geometries. That you would go to a CBN type tool. At the worst case, you maybe go with an EN type tool where you have a little bit more robust cutting edge. But just for anyone that doesn't know the ISO material code, PMKNS, so that's steel, stainless, iron, non-ferrous like aluminum, brass, copper, and then S is titanium, Inconel, and cobalt. Any heat-resistant alloys or difficult to machine alloys tend to go in the S group. So with the 3, you can do grooving, partial plunging, profiling, turning, and finishing. So it'll do all of those, kind of an all-around insert. We talked about EH in our new products presentation, but just to give you where this fits in, the EH is mainly for steels, but secondarily can be used for stainless steel and iron. Not recommended for aluminum or titanium. And then again, not heat treating alloys. And this is a grooving and part off geometry. You want to apply this one when you're under really heavy feeds. So if you're using our Y-axis part off system, or you're using really heavy feed, sort of over 12 thousandths per rev, then the EH is kind of a good system to use. So steel, grooving, part off. FB is a finishing geometry, so it's primarily finishing. So you want to use this as a secondary tool to finish up a groove that requires a very fine finish. And that's good across all materials except for the heat-resistant alloys and the hard materials. So no titanium, no Inconel. Titanium, you would want to apply the WT geometry that has that's been produced for titanium machining. So great geometry to use in finishing. The WT, so this is the geometry for titanium. Not great in steels. Secondarily, you could use it in stainless and all the other heat resistant alloys like Inconel. Not good in iron, not good in non-ferrous or hard materials. It's an all-around insert pretty much for grooving, partial, profiling, turning, and finishing. The 3V, so the 3V is a couple of variants. You have the 3V and also the 3VIK. So you have an internal coolant insert. If you have a heat-resistant alloy that you're machining and you need to get coolant right under the chip to improve your tool life, the 3VIK would be the go-to. It's mainly grooving, partial, profiling, and part off. So steel, stainless, iron, non-ferrous as a secondary, as an alternative recommendation. And then of course, heat-resistant alloys. The E, so the E is all materials, grooving and part off. In the EN, so the E and the EN are very similar geometries, as you can see. And the EN is just a more negative version of the E. So if you have to be a little bit more aggressive with feed, if you're running the E, you could switch to the EN. It has a little bit more robust edge protection chamfer, I think is what the Germans call it, in the front. So that's good on all materials except for hardened materials for grooving, partial, and part off. You also have the availability of an IK version. So when you're machining and you need to get coolant underneath the chip, you have that available as well. The 5 is an insert that a lot of our application and sales engineers swear by. They apply it pretty widely across a lot of different applications and say it works really well. That's for steel, stainless, iron, non-ferrous, and also heat resistant in grooving, profiling, turning, and finishing. So it's kind of does the profiling and turning. So kind of an all-around insert. The L is very similar, as you can see, to the 5, but with the exception that you have a kind of a lower profile, so a little bit more beefier insert. It doesn't stick up as much on the top face there. So for grooving, partial, profiling, turning, and finishing across all materials. The A, so the A is another one that's widely used. The A gets its name, I think what I heard, it looks like an angel wings here. But the A is excellent in partial profiling, so, or plunging. When you're plunging in and you're not making use of the full insert, you can use the A geometry across all different materials. So grooving, partial profiling, turning, and finishing. The K, so the next two are the K and the KF. So the K you can see is more open, and this is grooving, partial profiling, and turning and finishing. So it's kind of an all-around insert, but it's really good at doing profiles. And then your KF, so on all materials, and then your KF is designed to do what the K does, but with geometry closer to the edge. So your chip breaking geometry is a little bit closer to the edge, which means it's more of a finisher than the K is. So if you have a really fine finishing to use, I would use the KF. If you have more roughing to do, I would use the K. The KF is because of these fine details on the edge. Be careful in stainless and difficult to machine alloys, as they would tend to stick in these little upstands and create issues. The F, so the F has two variants, so the F and the FY. So the F is good on all materials for grooving, profiling, part off, and finishing. It is mainly a finishing insert, but it's great on hollow tubes. So anytime you have a hollow part or a very fine part that you don't want to put too much pressure on the part, you can use the F. The F is not good in partial plunging, so the FY is created to add that to partial. So there's a little bit, the difference here is there's a little dip in the FY in the very center. So you'll see the edge profile, it dips down just a little bit and allows some partial plunging. That's good in steel, stainless, iron, non-ferrous, and heat resistant alloys. The H is designed as a very aggressive tool. You can do grooving, partial, or profiling. Just a word of caution, profiling means that you're profiling with this part of the insert, not up here. So this is a plateau that your chip needs to hit and curl. but you can do profiling as long as you keep it sort of around just above the radius of the H geometry. Not good in sticky materials like stainless or titanium, but covers the rest, so steel, iron, and non-ferrous. HR is a complementary product to the H. So this has partial cutting capability and grooving capability. So this is going to crease the chip up really nicely. Again, M and S materials, be careful. It's an alternative recommendation. All right, that's the end of our training for today. Please join us back here for future trainings on our YouTube channel. So just hit that subscribe button and get alerts when we put a new one up. And also join us for the live training that we host throughout the week. I'm Edwin Tunney, Training and Technical Specialist for Horn USA. Thanks and have a great day.